Yep, we're live and ready to go.
Okay, so this is my talk on designing systems for scalable games. Now, the purpose of this talk is not really to teach you how to be, like, I'm not going to teach you specific programming techniques. Instead, I'm going to be teaching you sort of generalized concepts that you can sort of apply to all your games going forward, and some of the things that you might not think about as a university student, moving into the games industry and sort of transitioning the way that you code from sort of game jam style and really quickly put together things to code that is going to be supported by bigger systems, essentially. My name is Ash. I'm a gameplay programmer at Lucid Games. We are here in Liverpool. So to start us off, so just a little bit about who we are and what we do. So we are the developers of the PlayStation 5 game Destruction All-Stars, as well as Switchblade and a few other titles that we've made ourselves. And we also work on projects with collaborators. So we work on Apex Legends and Jedi Fallen Order and Hot Pursuit. So we work with EA and Respawn on those. We're located in Liverpool. We have two offices. We have a big one, a small one. One is mainly for sort of in-house projects, and the other one is for projects that are done by other studios, essentially. So yeah, there's a few of our games there. Destruction All-Stars in the top left. We have Switchblade in the right. Apex Legends. Some quite big names. So I guess to start off, we'll talk about what a scalable game is. That would help, wouldn't it? So a scalable game, and I sort of struggled to think about what this was while I was putting this slideshow together, because it's a bit of a wide concept, really. And I sort of came up with a scalable game is one that can adapt to increased or decreased demands, whether in terms of performance, maintenance, or feature set. So that means when you take your game and you need to be able to scale it up or scale it down and have it still function as expected. So, you give it more CPU power, it runs faster. You give it less, it runs slower, but it still runs, essentially. That's not just CPU power, but just scaling in general. So sort of, how easy is it to add a feature to the game, and how easy is it to remove a feature from the game, for example, because these things do happen in the games industry. So I've sort of separated it into three different groups. So there's ease of implementation. This is sort of how easy is it to implement a new feature into the game. How well does it scale? So usage scalability. Can the system still operate as expected when provided with more or less resources? And code reuse. So does similar code exist in multiple places across the project that you can sort of hook into and reuse and sort of cut down on code bloat, essentially, because we'll go into a bit more why later on. Bit of fair warning. There is a few memes in this presentation, and you'll see why. So going on to the first point that I mentioned, the ease of implementation. Just a few tips on how you can sort of reduce needing to refactor things. So when you're making a feature in the game, it's very easy to just go, oh, I'll just stick it together really quickly, and then I'll make another one that does the same thing later on. And you're not really thinking about how this is going to scale well in the future. So if I made a feature let's say I have a door and a button, and I want the button to open the door, it's really easy to just say, oh, I'm just gonna write some code that the door is like inside the button, for example, or the button is inside the door, and they're both like really strongly connected. And then your designer comes along and says, actually, I want two buttons to open this door, and suddenly you're screwed. So that's sort of it's about thinking ahead in the future for things that you might not need, and just putting in that little bit of extra work to make that happen. So it's sometimes, almost always, impossible to know every feature beforehand. So it might be when you're at university, it's easy to think that you're just going to go into the games industry and you're going to be given a design and told to go away and code it. That is not what happens at all. What will actually happen is your designer will come to you and say, you need to do this. And it's your job to then go back to them as a programmer and sort of say, this isn't going to work, or we can do this, but with this limitation. And it's sort of this constant back and forth between yourself and the game designer, and not just you being given the design and told to go away and do it, essentially. Making it easy for other departments. So if they come to you and say, we want the door that opens, it's your job to then go away and make that door, but in such a way that they can then later come in and say, actually we want it to swing a bit slower. Actually, we want the hinge on this side, because that's what they do. They have no idea what they're doing at the beginning. So expose key variables and properties is the main thing to take away. Make it so that they don't need to contact you to be able to adjust these slight little tweaks and modifications to what you've made. They can just go into this asset, change it all in one place, and go away, leave you to do what you want. So second point, usage scalability. Can the system still operate as expected when provided with more or less resources? So you have no idea, essentially, what hardware your game is going to run on, unless it's an exclusive game, and then you know the exact console hardware. But this also applies to server usage. So, for example, if you're making a multiplayer game, you have no idea. You can sort of guess, but you don't really know how many players are going to be playing this game. So you can go away and say, we aim for 1,000 players at once, for example. But then your game might become an overnight success, and you might get hundreds of thousands of people trying to connect to your servers, or you might get one player connecting to your server, and then you have to downscale. So it's about sort of designing with that in mind. Asynchronous functions. So especially on the server, because in a game where you're running a dedicated server and you're running multiple clients that connect to that server, the server is going to be extremely bottlenecked. And you need to be able to run those things sort of as they come, and not clog up the server bandwidth with those requests. You're making best use of the server, which is good when you're working with a publisher and they say to you, this is the server we're going to be running the game on. Make it as cheap as possible for us. So making best use of that server that they give you is always good. Code reuse. Now, this is one that, as a university student, you're probably not going to be thinking about, especially when you're in the sort of game jam mindset where you're going into this and you're making a game and then you're throwing the game away and never looking at it ever again. Code reuse is quite a big one, in that there's this thing called the single responsibility principle, which is sort of each class should only have one responsibility. So if you have a door class, it should only be a door. If you have a button class, it should only be a button. There shouldn't be a big class that's like door button implementation or something like that. Make sure that everything is only doing one thing. That way you can modularize it, you can remove things, you can add things without them all getting all messy and mixed up and that kind of stuff. If a function is too large, break it down. Like I said, don't have a function that's like, this does x, 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 y, 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 z, z, z. Just have one thing that does one distinct thing. It's easy to test. It's easy to fix. If it breaks, everyone is clear on what it does. It's good all around. Programming patterns. I'm sure you've all encountered these in your time. They're very useful. Inheritance, subsystems. So subsystems are, not really sure if they're an Unreal specific thing, but they are essentially systems that run independently. So similar to a sort of singleton, but not quite. We use those quite a bit in all of our games. It's just a single system where you can access a bunch of different data, all in one organized place, really. So you might have a subsystem that's like player list subsystem that you can access every single player in the game from, for example, without having to loop over and over again in like multiple different places in the code. And a little meme there for you. General practices. So this is sort of combining all of those three things and putting together a sort of a couple of guidelines that you should follow. If you're making a network game, it's generally a good idea to use client-side prediction. It might seem quite scary at first because you're like, oh god, I need to do a lot of math to work out where someone's going to be on the client, and then I'm not going to authenticate that with the server. But it's really it's easier than you think, and it adds a lot of value to the game. Players generally, when they're playing a game, they expect instant feedback for pressing a button. They don't want to wait for the server to respond and take 10 minutes to come back with a response. So what you do is you for example, you take that button press and you make something instantly happen on the screen. And in the background, you're then sending that request to the server. And the server can then do its thing and come back whenever it finishes, rather than having to wait for that client to do something. That's just one way that you can make your game sort of feel better without needing too much work. And now this is a big one, because try not to write code that fails silently. So if you're writing some code, it's generally a good idea to sort of make sure that if it breaks, you know exactly where it breaks, why it breaks. Don't sort of... I know how easy it is to just slap a try catch around a block of code and be like, all right, fixed, done, let's go. But that's just going to end up compiling later on down the line, and you're just going to get an error that you don't expect and you can't fix because you don't have any output. So just make sure that you're sort of outputting. If you think that something might crash because of a null pointer, crash it. Slap an error log. Don't silently fail that error. I think I've messed up my presentation here because it's not going. Oh, there we go. Yeah, don't continue running code that's already crashed. Just output it exactly where it's broken, then you know where to fix it. So, with this in mind, a big thing that we use at Lucid is called the gameplay ability system. Now, this is quite a Unreal specific thing, but a lot of the concepts will be transferable to other engines like Unity or your own engine or anything like that. So the gameplay ability system was originally designed for MOBA games, so games like League of Legends and Smite and all these different MOBA games, where you have distinct abilities and they interact with each other in so many different ways that writing code for them would be a nightmare, end up in spaghetti. And these abilities need to interact with each other. And this is a sort of nice way of doing that, but you can also apply this to every single system in the game, and even if it's not a MOBA, it's a really interesting concept. So gameplay ability system is a collection of systems and data that define how actors behave and interact. I appreciate that this is going to be a lot of information that I'm going to throw at just try and keep up as you can. So the gameplay ability system is comprised of I think it's about 6 or 7 different components, maybe a few more. So there's attributes, there's abilities, tasks, effects, tags, events, and queues. And all these different things allow you to write code in such a way that each system is completely independent of each other. So, for example, if you have a character and you want your character to have a dash ability, or just like a general running ability, you can do that without having to write specific code where that dash interacts with other code, for example. And I'll go through each one of these and explain why. So attributes. Attributes are a numeric value that can influence abilities, effects, and more. So traits are defined in code, added as a set, and can be modified through effects. So for example, you have a character, and your character has a health, has a max health, it has stamina, max stamina, this sort of stuff. So these are just general numerical attributes that your character or your game has in general. Ability. So these are the sort of if you're familiar with League of Legends, these are your like 0 to 4 keys, I think, 0 to 3. These are your abilities that you use. So these are custom gameplay logic that can be activated, executed for a period of time, and then terminated. So for example, if you have a character, you want it to slide, run, vault, jump, shoot. These would all be abilities that can activate sort of independently, and you don't need to write code for these to interact with each other. So for example, if I'm shooting, if I have the shoot ability active, and that means I'm like aiming down the sight, you want to be able to say, okay, well, I'm aiming, so I don't want to be able to slide, for example. And the way that works is that each of those abilities are independent, and you can define using tags, which we'll get to in a bit. You can define using tags sort of those interactions. So you can say, while shoot is active, don't slide, or don't vault, or don't run. And these are all things that you can do without having to write a line of code. It's all just like a string-based system. So abilities can apply effects, they can apply tags, and each ability has a unique purpose. So it's sort of like a function. So it's like if you imagine a C++ class, you can imagine that you have a run function or a jump function. Tasks. So these are things like functions. So if you imagine that a ability is then a class, you can imagine that a task is a function that task can use. So abilities can use different tasks. So a reusable piece of logic that can be triggered from abilities. So if you have an ability that says run, you can then use the task apply force to sort of move to that position. And then any other ability can also use this task. So it's like a sort of reusable piece of code. Effects. So effects are a structure used to modify the state of an avatar/player. That sounds a bit daunting, doesn't it? So these are things like status effects. So if I run into fire, I then have the burning effect. I then have the regenerating effect. I then have the poison effect. These are like sort of states of the player, and these can interact with abilities and attributes. So if I have the burning state, we can then block off certain abilities that say, if I'm burning, I can't do this ability. If I'm regenerating, then my health attribute will go up. If I'm poisoned, it goes down. If I'm rolling, so as you activate the roll ability, you then apply the rolling effect, and then anything else can read that rolling effect without having to be like, you don't have to write specific code for that rolling ability. You can say, okay, they now have this string rolling tag, which means they're rolling. And it's a bit like a state machine in some ways, if you know what that is. So yeah. Tags. So if you imagine that you have a player character, you can think of the player character as having like a list of strings attached to it. So these are the sort of strings used to describe an actor/player status or to control the flow of the game. So for example, you might have an airborne tag. You might have a rising tag for that airborne tag that says okay, well now I'm in the air, but I'm going up. And then another ability might say, if they have the rising tag, then I can do this ability. Otherwise, I can't do this ability. And the nice thing is that you don't have to write the code for these specific interactions. It just happens that the interaction happens sort of through these tags instead of via code, and it makes it a lot cleaner and a lot detachable from the main system. Events. So these are sort of like delegates in C++, if you're aware what those are. So these are broadcast by the ability system to pass data around or initiate things. So for example, an ability, you might use an ability to damage another player, and then that player, once their health attribute reaches 0, they'll then fire off a death event, and then other things can listen to that death event, such as the queues, which we'll get to in a second, and you can do specific things on the back of those events, so staggering or death or different things, and everywhere in the code can listen for these events, and it makes it a lot cleaner. So queues, these are a bespoke piece of logic tied to a specific cosmetic effect. Now, when you think of a cosmetic effect, we're talking sort of like the VFX or the sound effects or that sort of thing. So, for example, if a player had a death event that triggered, you could then say, okay, well, you could say to the artist, we have a death event now, and we want you to add some VFX or some sound to this death event to show the player what happened. So you can do a one-shot. So a one-shot queue is sort of a this plays a VFX thing once, or persistent one where it lingers around for a bit and then disappears. So one example of that is, let's say a player has the burning tag. So they've walked through some fire, they have the burning tag applied to them, and then you can then say, okay, we're burning now. So we have the burning event trigger, which we've just gone over. So we have a burning event here, and then we can say to the VFX artist, we need some burning effects on the player for on this burning event. So they'll come in, they'll make some VFX, and they'll tie that to a queue, and then the queue will trigger and apply that effect. And it just sort of, it's really great for detaching systems and being sort of working independently as programmers away from your design team and your VFX team. And it's really good for efficiency in that way, in that everyone can work on their own thing without having to wait for anyone else to finish what they're working on. So yeah, that is the gameplay ability system. And I appreciate that that's probably a lot of information to take in. But once you get the hang of it, it's really flexible. It's really great for almost any game, not just a MOBA, for FPS games, third-person games, for strategy games. You can use this for anything. So I would strongly recommend doing a bit of reading on this. I have a reading list here for you. And I'll get these slides sent out to Olivier or Kieran or someone and make it so you can read these. But it's a really great system, and we use it in pretty much all of our games now. So just as like a quick demonstration, well, not sort of like an example of how where you would use this system is, let's say that we want a go back here. So let's say we want let's say that we want a dash that goes into a roll. So you can't roll unless you're dashing. So what you would do is you'd make an ability that says dash. And then as you are dashing, you would apply the dash tag. So then you have player.dashing. And every system in the game can then read the tags that the character has and say, okay, they have the dashing tag. So then you'd have a rolling ability that says, if the player has this tag, then they're allowed to use the roll ability. If they don't have the tag, they're not allowed to use it. So you can sort of chain these things together and define gameplay just through a selection of strings and checkboxes. Essentially, you don't really have to write any code to interact between them, and that's the nice thing about it, really. So yeah, I mean that's sort of all I have on gas. I did have a bit of a demonstration plan, but I don't know if my PC is going to allow it. It's in UE5, you see. Don't know if my PC is going to lag now. Can everyone see that? I hope so. So this is in UE5, and what I've got just is a little demo scene here, with a trigger and a so this is like a sort of box trigger, and as the player enters it, they will get the burning tag and they will be set on fire. And you can see my health bar there is also draining. I have a dash ability, and I have a rolling ability if you're dashing. I have a jump ability, and I have a ground pound ability. So if I have the burning tag, I can also roll, and then my fire goes out. And I haven't defined any of these interactions in code. I've simply just done it through tags. So I appreciate that. I don't know how much experience you'll have with Unreal, but it should be fairly understandable. If I find where it was. So here I have the gameplay ability for rolling, and you can see on the right here, hopefully that's clear enough. You can see a list of different tags. So you can see ability roll. So we have a montage, and a montage in Unreal is just an animation essentially. So this is just the rolling animation. So this is the animation to play. We have the remove effects with tags. So if you currently have the effect.burning tag, then remove it when this ability activates. We have the ability tags. So this is the one that gets applied as you activate this ability. So ability.roll, and cancel abilities with tags. So if you're dashing, we cancel the dash ability. We can also block abilities if we want to. So activation block tags, we can block from rolling again, so you can only roll once at a time. We block the leaping ability, so you can't leap, and we block the ground pound slam ability. And you can see all of these interactions are done just via strings, and it's really quite useful in sort of keeping the game clean and modularized and section off. So if I open up this ability tag thing, you see we have this massive list of strings here. So we have ability, effect, gameplay cue. So as you activate this ability, you'd say, okay, well, I activate the roll ability. And if I go into the activation block tags, this is where we block the leap tag, we block the roll tag, and we block the slam tag. So what we can also do is, if we go into this activation block tags, we can so remove effects with tags. So in the roll ability, so if we go into this again, if we try to roll through the fire, you see we don't get set on fire. So it gives you sort of an invulnerability frame there. And it's really easy to just keep on defining these over and over again until you have something that you like. So if you look at another ability, for example, and I'll make this project available for all of you so you can tinker around with it and see how it all works, because it's quite a lot to go through in one session to set all this up. So here we go. So in Blueprint, you can define these in Blueprint, or you can define them in code, which makes it quite flexible. So you as a so generally how we work at Lucid is we will have a designer that comes in Blueprint and designs and sort of experiments with abilities and sees what works and what doesn't, because it's easy for designers to come in and say, we want this to happen or we want this to happen, but until you actually play it, it's quite difficult to get a feel on how that works. So we'll have designers come in and sort of blueprint out abilities and see how they work, because blueprints are generally quite slow, so we don't tend to use them in our games. So once they've defined this ability, we'll then come in code and we'll redefine that ability in a way that's more cleaner and faster. So just for example, we have event activate ability. So this is the activate ability event, and anyone can activate this ability from anywhere. So usually via input, but it can also be through game events. So we activate ability. We play the montage, so the animation. So we play the dash animation. And on complete, so when the dash animation is finished, we end the ability. Or when another one, so on blend out is when another ability is activated. We want to smoothly transition those animations. So we also end the ability there. So uninterrupted or uncancelled, we cancel the ability. And now this is all just the movement code. So this is just moving it forward by a certain amount, and then we end the ability. So you can see it's really easy to mess around with this and define your own abilities. It's really useful. Open this. Go away. Thank you. Where was it? So just to mess around a bit and show you what you can sort of do with this. If we remove this burning tag, this effect.burning tag from the roll, so now as you roll, you'll no longer put the fire out because you haven't removed that tag. You can also do things like you can also add things here. So if I add, for example, the regen effect, when I roll, I should start regenning. Okay. Yeah, I'm regenning health now. So you can see it's easy to sort of mess around with these and make your own things, and it's good for rapid iteration on gameplay, where you don't have to spend hours writing the code and then testing it and seeing if it breaks, and memory management and all those things. Yeah. As I said, I'll make this project available so you can all download and have a go yourselves and experiment with that. And yeah, that's kind of it for me, really. Do we have any questions?
Hello, I'm currently scanning the chat. By the way, thank you, first of all, Ashley, for your talk. That was very interesting. Yes, of course, I will make sure that the slides and the projects are available to everyone. And of course, guys, if you've got any questions that you'd like to ask Ashley, go for it. Don't be afraid. Ask him messages. Ask him questions using the YouTube chat, or send me a message via Discord, and I'll make sure that the question is read out to Ashley.
You can also
Yeah,
ask me just general questions, not just about this, just about what it's like in a game company or anything like that.
No questions in the lab. Great talk, though, says Kieran, aka Nakash Gaming. Well, I assume it is Kieran. I remember his username. Oh, but Ashley, you did your undergrad and postgrad at the University of Lincoln, didn't you?
I did, yeah. I did my games computing degree, and then I did my master's in that as well.
Which is brilliant, yes. Yeah. And I remember you also struggling finding a job in the games industry at first. It was a bit tricky for you, but in the end, you persevered and you got your dream job at Lucid Games.
Yeah, I mean, all I can say is just keep trying. You're probably not going to get the first job that you apply for. It's important to just not be discouraged, really. Just keep applying. And yeah.
Do I have one question that just popped up about grasp or solid or gas? Do you think you can answer that?
Not really sure what grasp is.
Solid?
Grasp or solid?
Otherwise, there's another question that pop up about, are there any networking patterns you would recommend for RTS style games? I'm working on one right now, and I realize now the scaffold way I was networking is holding me back. That's a very good question by Vesper.
Oh, so networking is a whole other different kind of beans. So in terms of networking for an RTS, you want to make sure that it's RTS is a sort of a difficult one because everything is relevant to the network at all times. So you can't really usually in a network game you would want to make objects sleep when they're not relevant anymore. But that's obviously quite difficult in a game where every unit has to move independently and all the time. So all I would say there is make sure that you're only sending in terms of patterns, there's not really a specific pattern that I can give you. Just make sure that you're only sending the data that you need. You don't need to know the exact state of everything at all times. It might be enough to send just the position or just the health, for example. Make sure that you're not clogging up the bandwidth with unnecessary information that might cause your game to lag. I mean, networking itself is we have specific people just for this kind of thing, because it's such a big task and such a big thing for people to write by themselves, and it's sort of networking is. I mean, I assume that. I don't know the exacts of your game, but I assume that you're going for like a client-server architecture and not sort of peer-to-peer. In that case, you want to make sure that the server is communicating with the clients in such a way that you're not listening to unnecessary information, basically.
That is indeed a very good question. I agree. I know, though, from experience that other RTS games are, instead of sending the state and the position of the objects, that they're sending the commands that the players are doing. And then they hope that the system are deterministic so that they reproduce the same result on every machine. And only every few minutes that they're checking if all the objects are in sync on every machine.
Yeah, it's determinism is quite a good thing that you mentioned that. If you send, for example, where the player wants to go, like where the player wants a unit to go, you don't then have to send every single position between that. You can interpolate between that and work that out on the client without having to send any extra information back and forth there.
No, it is interesting. Also depends on what is it? I know some RTS games already use existing libraries to use, for instance, a Steam server or a Microsoft server, and they don't have that much power of what's happening behind the curtain. They just say, yeah, we just use their network system service, and then that's it.
Yeah, I mean, making an RTS game by yourself is generally a big thing. I wouldn't recommend it. uh, just because of the scale of it. It's such a big thing to be able to do that by yourself. But yeah, good luck to you, man.
Yeah, Vespa says thanks, which is great. Yep.
Any more questions about game dev in general? What it's like at a studio? Anything?
Just briefly, I'm having a look as well at what the question was about Grasp and Solid and Gas. It's a principle or object-oriented design.
So Solid is the single responsibility principle.
Yes. Yeah.
And Gas is the gameplay ability system. I mean, they're not. I wouldn't say they're independent of each other. You know, with Gas, you have these abilities that are single things that only do one thing, and that is sort of the single responsibility principle. It doesn't just apply to the code, but sort of everything in your game. So it's sort of a general. It's sort of a good idea to implement those things generally, and not just stick to one pattern or another pattern.
Any testing task for juniors? Ask Oleg.
What do you mean by testing task?
Perhaps he wants to rephrase the question with what do juniors do when they start at the studio? What is the daily task like? What is the daily job like when you start as a junior?
So, as a junior, I mean, it sort of depends on your experience level and how comfortable you're feeling. But generally, we'll tend to. I mean, when I started, I was put on sort of a project that wasn't sort of big budget. I was put on a project where I could experiment and get things wrong sometimes and see what works and what doesn't, and sort of get to grips with Unreal because I myself, I'd never used Unreal before I started Lucid. So this was a good experience for me to sort of get into Unreal and figure out the ins and outs of Unreal. But generally, if you are put on a bigger task, and that is sometimes the case. So if you join as a junior, you might be put onto a sort of big project. But if that is the case, we'll give you some smaller tasks to do. So sort of bug fixing or a task that isn't likely to break the entire game, essentially. So you can find your feet and sort of build yourself up to the bigger tasks. And we try not to put too much pressure on you, so you can sort of do these things in your own time. There's no pressure on breaking anything. So I feel like we're quite good in that respect. To get into the company, usually do they have an? Yes, I think we do have an entry test. It's just to make sure that you sort of have a basic understanding of C++. I don't think we really care if you're proficient in Unreal or if you've only used Unity before. We don't really care about that. We're interested more in your potential in what you've made before and where you think you can take that, rather than a lot of experience in Unreal. So if you have, I always say when I do these things is that your portfolio is the most important thing that you should be working on in uni. Make sure that you're going the extra step in your assignments to make them look presentable and to make sure that when you show these to potential employers, they're gonna see those portfolio pieces and they're gonna know that you have the initiative to take that a bit further than you might have previously done. And that's sort of what we look for. We look straight for the portfolio, see what you've done before. If we like it, we'll take it from there.
Yep, that was a fantastic answer. Thank you, Ash. Should answer your question as well, Oleg. Thank you very much for asking them. Do the people in the chat have any more questions? If not, I will say thank you very much, Ashley. Thank you very much to the viewers as well. Also, thank you very much, Ashley, for joining us, for telling us quite a lot of detail about how it works with scalable games at Lucid. It's a good insight. It's great seeing how things work behind the curtain. Yeah, I've said behind the curtain a few times already, but it's fantastic. It's also great knowing more people working in the games industry.
I appreciate that a lot of this gas stuff is quite Unreal specific, but I think that you could transfer a lot of these concepts to anything that you're doing, really. It's good practice in general to modularize your code and make sure that you can add things if you need to without having to rewrite the entire thing. And
Yep, people are thank you, Oled, thank you, Jordi, thank you, all the viewers. Thank you, Kira and PogChamps all around. Thanks, Ash. And Magic as well, thank you. So a lot of people thanking you. So Ashley, I think that's the end of this broadcast. Thank you very much. Thank you, viewers. I'll see you around next time. Join us for the next Enhancement Week talk as well. Bye-bye.
Thanks for having me.